Hey, Lady Ada, what is this?
Hello, everybody, and welcome to the Adafruit Show and Tell. This is our favorite 20-ish minutes of the week where we get to see what people around the world are working on. We peek into their workshops, their studios, their basements, their bedrooms, their WeWorks, and what are they crafting, hacking, 3D printing this week? We're going to find out. Kick it off with some Adafruit folks, and then we'll call on visitors from around the world. So let's start off with Scott. Scott, what are you working on here?
Hello. We'll see if this demo works. Well, I'm working on Bluetooth. I do have some of the Circuit Playground Blue Fruits, the new ones, but I'm actually using a Feather because then I can hook up a debugger. So what I've got going here is it's the very basic code.py. And what I have here is an app that I'm working on for iOS. And the hope is that I can use this app to read the code.py from the file. Now there's no button I can actually hit, so I'm actually going to just cheat and restart the app if all goes well. And we'll see. Da-da-da! It worked.
Okay,
so now,
what happened?
So the screen now lists the contents of the code.py. So this is what my code.py is on the file. Ignore this warning. You can just dismiss it. So what it did is it discovered that this is a CircuitPython device. It connected to it, and then it read the file off of it. This cord here is just so that I can debug the iPad. It doesn't actually have anything to do with it. So
Got it. So it's all Bluetooth. It's connecting to the device that it knows about, and it's like, I want that code.py so I can show it. And then you could do things like edit the code.
Exactly. So it's doing like discovery. So if there's more than one CircuitPython device that it sees, it won't connect to it automatically. But if there's only one, why not just connect automatically, right?
Yeah.
And then I was playing around with this. It doesn't work yet, but it's meant to be like a drop-down status bar that you can. It's all the math is wrong for where it is.
JavaScript.
But it's supposed to show you like your REPL output. So your serial output, the first line will go there, and you'll have an indication of whether it's connected or whatever as well. And then if you need to select a device, what you'll do is you'll use this to select which device that you're talking to. Once that code works.
I actually kind of like the flyby REPL. It's kind of cool. It's like just swooshes.
Right? Yeah, it's definitely wrong. And then there's no way to hide the keyboard, but the editing does work. It doesn't. Oh, emojis. It doesn't send it back to the device though. So
okay,
Oh, yeah, got it.
That's
step by step.
One of the next steps for sure. Yeah. First, I got to get it editing this way, and then saving, and then we'll auto reload like we do with USB, and it will rerun your code.
All right, and I'll preemptively let everyone know, yes, of course, we will have an Android version too.
Hopefully.
Yeah, hopefully. Okay.
This should work on Android as well. Yeah.
All right, well, thanks so much, Scott.
Thanks, Scott.
Thank you.
Super cool wireless technology.
Let's go to
Next up,
JP.
JP, because he's got a buddy.
Hey guys, I do have a buddy. I'm not your buddy, JP. No, seriously, you are my buddy. No, seriously, I'm definitely not your buddy. And you, my friend, are no ventriloquist. Oh, well, that's probably pretty true. But what you can
We're
see
trying.
we've got our little friend Slappy, who is a ventriloquist dummy, and I've been working on coming up with some ways to add monster mask eyes to ventriloquist dummies because A, ventriloquist dummies, and B, Halloween is coming up. Yeah, it's true. It's coming up very soon. Good. Then watch the show tomorrow, won't you? Okay, yeah, everyone should probably watch the show.
All right. So a lot of people, in each show we say we don't have loans or venture capital. It's probably because no one will give us money at this point. Yeah. So we're doing a good job with that. All right, JP.
Some VC is like, I was going to invest in you, but you made my kids cry.
Yeah, we're very proud of it. But
it was crazy.
Yeah, this is what we spend our time on.
Yeah.
All right, so we'll show your videos and more on tonight's show.
Super. Great. Thanks.
Wow.
Tomorrow.
Thanks, JP.
Okay, let's go to Paint Your Dragon.
Phil B.
Oh, crud. Okay, sorry. I'm still laughing at that. You destroyed me.
Yeah.
Hey, it's sort of a project I've been working on. I haven't shown any old retro junky tech in a while, and I thought I'd show something. You remember I was collecting old computers, and I had this rule because I got too much crap. If I'm going to collect something, it has to be able to fit in a shadow box on the wall. So let me switch cameras. Got a little tiny item today. Vintage, a vintage calculator. There it is.
Ooh.
Doesn't. Anyway, there is a calculator there. Casio SL800 from 1983. So interesting thing about this, it's a credit card size calculator, and big whoop. Everybody's bank at the time would give them a so-called credit card size calculator, but they were all these chunky things.
Yeah.
And the SL800 is the only calculator that was actually the size of a credit card.
Jeez.
Even later ones. This is 36 years ago.
They were incredibly innovative. Like whenever you look at like old Casio stuff, you're like, how did they do that?
Yeah. And so this was only around for a year before it was discontinued. And the reason is because people would stick it in their wallet, and it would very, promptly after some flexing would cease to work. So I'm lucky to have one here that still works, because that's kind of rare. And if you're curious, I do have one that doesn't work. And you can see a bit of what's going on in here. Some tricks we've seen in other projects, like the IC is flipped 180 and inserted into a cutout in the PCB, very thin PCB.
Upside down, yeah.
The interesting thing is the passive components. I don't know if these were just not like standardized yet, or just the form factor was so weird they had to come up with their own. So they're just these like wafer thin pieces of whatever capacitors are made out of, soldered to the PCB, but they're very strange shapes. Large XY area and very thin.
Well, there's a lot of Japanese like passive component manufacturers. Casio probably, was like, hey, this is our coolest design thing ever. Can you make us a custom ultra thin capacitor? Because people were only moving to surface mount at that time anyways.
Yeah, it was pretty bleeding edge. So I just thought that was interesting. Something that was going. It'll be on my wall at some point.
That is really cool.
It's neat that still 36 years later, no one has repeated that feat.
I gotta say, like, solar cells are amazing because that thing still works. Like if it was a battery, it would have been completely destroyed.
Yep.
It's made its money back. It only took 30 years.
All right.
I'm on the lookout for a Rex 6000. It was a PMCIA calculator that plugged into a computer. It was also
I remember that.
Yeah. So anyways, if anyone knows where I can get one, I guess I should look on eBay. Okay.
All right. Thanks, Obi.
You bet.
Okay, next up, let's check in with Brian and Brian Scream, because you got that set up.
Howdy. So I've been working on the MPU 6050. It's a 6-axis motion thing with an accelerometer and a gyroscope. It also does temperature. So right now you can see this is loaded the gyro code. That line at the top is the current temperature, just to show it off a little bit. So I'm going to grab the thing in my hand and I'm going to hold it in my fist and twist my fist in different directions. So this way I'm going in one axis. You can see going that way. Now I'm going to go back and forth. You can see the other one. And then I think if I rotate this way, you can see the other axis.
Yes, you see the blue, red, green, and each one of those is an axis.
Yeah, and so it's clipping right now because I don't have the range adjustable yet on the gyro, but I do on the accelerometer. So right now I'm going to try and upload the accelerometer code. Here it comes. And
live Arduinoing.
All right, here. Okay, cool. So there it is. The scale on this is much lower than the gyroscope, so you can see it looks much smaller, but I'm whacking it against the table and do all kinds of fun accelerometer stuff. Maybe when this other stuff gets off the screen, it'll work. Anyways, that's it.
Great.
Yep. And then one last thing. This is the OLED I've been working on. Oh,
wait, hold on.
You go to the
You
camera.
gotta hide your.
Sorry, there's some stream stuff going on here. Okay, there you go.
Okay. All right, so this is a big OLED.
So this is the big OLED bonnet I've been working on. I just finished the driver last week. And yeah, it's nice and big. It's easily readable from across your desk. Yeah, nice little display.
Chonky.
Yep.
All right, nice work.
Thank you.
Brian, always
Good.
bringing the Cooltronics, cutting edge.
Okay,
Sometimes literally gets himself on the edge. Still cutting edge.
Next up,
Okay,
Aaron.
next up, Aaron.
Hello, I'm doing some more costume stuff this week, and I'm working on a 3D printed mesh bra, which is kind of exciting. Right now I have kind of a fire code running on there. The way this is working is I have used that fancy trick of 3D printing some different scales onto some mesh fabric, but I made them hollow on the back, so they are exactly the right size to fit these little neopixel dots inside. And it's real easy to just hot glue them right in there. And then I just plug in a gemma, and I can make armor and all kinds of different costume bits that are sort of soft and flexible and really cool with individual lights that just animate inside. So also working on a mermaid scale choker necklace that's gonna kind of go with this too. These ones are heart shaped, which makes me really happy in a girly kind of way. So I'm gonna do a mermaid scale one too. And working on a tutorial for that this week.
I love that we're taking like the sci-fi festival costume technology and we're just taking it to the next level. It's like, instead of just foam, it's like now it's embedded LEDs. So this is very, I think everyone saw that Twitter video of the fellow who kind of came up with this technique, and everyone's like, I gotta do some cool stuff with it. And he was doing dragon scales, but we're doing heart scales. Okay.
All right.
Mermaids also have scales, everybody.
Yes,
Dragons aren't the only scaly things out there.
I have to do a whole mermaid tail with it.
I know. You're working on your leg. It's going to be a 20-day print, but you'll eventually get one gigantic.
It's one of the best projects, I think, because 3D printers normally, they don't get out of the basement or workshop, and you can only print so many, Yoda heads. This is something that you can print and then bring out with you and say, hey, I made this on a 3D printer.
Yeah.
So, okay.
All right, sweet.
Cool.
Thank you, Aaron. I was bringing the cool, colorful stuff.
Next up,
down, Pedro. Who are from space.
Yes, hello Earthlings. Hi. This week we have a very fun project using the Adafruit monster mask. There it is.
I think the dog is like, what is going on here?
dog is like, send help.
He's telling me to say things.
So this week's project, we're splitting apart the monster masks, and I'm not going to be able to concentrate with that.
Too much. He's already wearing the eyes. It's all he's got a lot going on.
Yeah, so we're using an extension cable to increase the length of this, so you can make these really cool antenna eyes, but you can also make a shorter version
like these.
With the standard little 9-pin
I'm already
connector.
wearing a head thing.
So we're using the Ninja Flex little, I guess, gut-inspired, what's his name? The director dude? Cronenberg style, I guess, like guts and stuff. This is from the previous project when we did the what was it, the Flesh Charger?
Yeah, it was like a gross charger that looked like an intestinal charger phone. Yeah.
Exactly. So it's like a modified version of that. All of the files are in Fusion 360, so they are completely parametric. You can edit these to whatever length you want and whatever like angle. So you can like hide all the batteries and the wiring that's going through all that. And then the case has a little spot so you can get the JST connectors through there, the USB port and the reset button. And what else was on there? The stemma connectors also. Ports for that. And these fit just on regular headbands. So is what it looks like. It's actually like a little skeleton version of it. It's just these compression springs that are holding everything together. And it's a super little simple build. And you can customize these to whatever Halloween costume requires eyes to be split apart.
It's perfect for my Jar Jar Binks cosplay.
I know. We were talking about how it's Jar Jar Binks, but we were like, we didn't want you to tell you to dress up as Jar Jar Binks. It's like kind of a hated character. So if you're gonna do it, you gotta do it in the right way.
Alien from Explorers.
From Explorers.
Yeah.
Yep. That one scene at the end where they're all dancing. So it gives it some life when you have like springs in there. You can be like,
Yeah, I like that it's springy. And what's neat is, like, when we were first working on the mask, we were like, oh, well, how are you going to, it's going to be in front of your eyes. How are you going to see it? It's like, well, eyes don't have to be in front of your eyes. They can be on top of your eyes.
Yeah, right.
You can
Take some
be
cues
creative.
from the animal kingdom.
Yeah.
Eyes on each side, too.
Yes, that's
okay.
true.
All right, we'll be playing these videos and more on Ask an Engineer in just a little bit.
Yep.
Thanks.
Thanks.
Thank you.
All right. Next up.
All right, next up, Melissa.
Hi. Okay, so I have this Halloween M4 here, and I threw an AMG 8833 sensor onto the back of it, and threw in a little battery. So now I have a little battery-powered thermal cam here.
That's cool.
And let's see it. You can kind of see it from there.
Yeah. You're warm. You're alive. I guess
Yeah.
good. All right, that looks cool.
I think the
Fast.
art challenge would be to get some like hot water and paint it on a piece of paper, and then maybe point at it and see if you can get it to look like a picture,
That's a good idea.
like a little happy face, because it's a skull. So.
But this is like perfect for doing this because it has the feather wing header on the back, has an M4 processor, the displays 240 by 240, and so I was kind of actually waiting for something just like this to come out for a while.
Yeah. That's super cool.
Yeah,
And then
looks
also the
great.
battery fits in between it too, so it's a nice.
Exactly. So it's just like a little 350 milliamp hour one.
All right, cool. Thermocam with the Halloween
All right.
M4.
Well, thank you so much.
All right, cool.
Yeah. All right. Next up, we're gonna go to Dave.
Hey, Dave.
Hey, Dave.
Dave B. And
Oh, wait,
Dave.
sorry.
Wait, sorry.
No,
Sorry.
they moved it around. Sorry, Ron and Thomas. Then we're gonna go to Dave.
Sorry.
Hey guys.
Hi.
Hi, Ron and Thomas.
Hi. So for Thomas's birthday last month, I got him a Pi Gamer, and we've been working with Make Code Arcade to work on different games.
Okay.
And recently, we walked through a little tic-tac-toe game.
Oh.
I did a lot of the organization, but Thomas, I had him work through all the logic of it and figure out how to do the different things. So he wanted to show it off.
Okay. All right. So do I have to? Okay, I'm gonna go for the middle square.
Middle square. Okay.
Okay. This is a lot of pressure here. Okay. Now,
right.
now it's your turn.
All right. Where you want to go, Tom? Here. Okay. Right there.
Okay. I want to take
You have to block.
block. Okay. Yeah. Top, middle.
Right
Good
there.
idea.
All right.
Yeah.
Okay.
All right.
I'm gonna
Well,
look,
I don't know.
Look.
Let's see. I'll go here.
Oh, fool. Okay.
Oh, no.
Middle.
And there you go.
Yeah.
Oh,
Victory is mine. Nice kidding.
All right.
All right. Well, that's a great logic. It works really well. It doesn't accidentally say you won. When you do win, it does say you win. It's really important. And the
Yeah.
graphics look really cool. I love the peaceful background.
Yeah. Whose idea was that, Thomas? Was that yours or mine?
It was Daddy's because I wanted like the woods, and I liked how he changed it up.
Yeah. We're working on going through how much work kind of goes into making a little program like this.
Yeah.
Because whenever he first got it, he wanted to essentially make
A really complicated
a
game.
first person
But
shooter.
I was going to put Minecraft. Yeah, and I think that's important to know because
Yeah.
it's one of the things I like about MakeCode is they actually. I know it's Thomas. It's like a lot, but we did simplify it quite. Like they did simplify it quite a bit, and you're dragging, dropping blocks, but you get the experience of it. But you don't have to write every single line of code. But you did an excellent job. It's a wonderful game. We're going to send you a free sticker.
Yeah.
Oh.
Yeah. Happy
Yay.
birthday, and that also means you get a sticker for showing your project.
Say hi, Em.
Oh, hey, you also get a sticker because you showed up.
You too.
Stickers for you.
So drop us a note, Ron, and we'll send out a couple stickers.
So I don't want you to fight over the stickers.
Thanks, guys.
All right. Cheers.
right.
Thanks, folks.
Okay, this time.
Sorry, Dave. For
this time
real.
for sure, Dave.
Sorry, Dave.
Hey, Dave.
Hi, guys. Good to see you. My first time here, so forgive me if I don't share the screen right. Here we go. Share
It's kind of new for us every time too, so
Yeah.
it's all good.
application window. And I don't know if it works to play this video, but I'll explain what this is.
Yeah.
I'm teaching my students about data representation. So what you're seeing here is ASCII values represented in binary with lights on a Raspberry Pi.
Ooh.
So I'm going to play the video, and this is at 1/10 the speed at which the program actually can see and decode the message. So
Okay.
1/10 speed. Here it goes. So you get 8 bytes at a time, as you can see. And this is just a couple of paragraphs of text about Python from Wikipedia. But it uses OpenCV and Python. And that's it.
Wow. So it's a binary code wireless transmission system using a camera and a Raspberry Pi so they can send messages back and forth.
Exactly. And this started as a project on the Circuit Playground Express where I had a message hidden in it, and I used a kind of 5-bit encoding scheme, just where number 1 equals the letter A and so on. And I had my kids advance through the binary patterns and try and figure out what the code was and see the secret message. And then I thought, well, let's have a computer program do the vision and decoding as fast as it possibly can. And so that was on this. Then I thought, well, this has 10 pixels. This has 64. So let's go to town and be able to show 8 bytes at a time, like almost 60 per second. So
Well,
just a lot of fun learning about computer vision.
Yes, it's a good demo. It's a nice, simple, great way to start out a project. The only thing that it's missing is a sticker. We'll send you one.
Yeah,
Email support.
Support at Adafruit. And then also, Dave, if there's a link to this anywhere online, email PT at Adafruit, and I'll include this in our Python newsletter that goes out every week.
Great idea.
Okay.
Thanks, guys. Good to see you.
Thank you, Dave. You did great your first time.
Good work.
All right, next up,
All
Dan.
right.
Hello. Welcome
Dan.
back.
What you got?
There we go. Okay. Hey, how you doing?
Hey.
Hey, not exactly electronics, but sort of electronics, I guess. I don't know. I picked up a scooter for pretty cheap, so I've been going through and rebuilding it. Don't have the electronics, so I'm kind of going a little old school, like just plain wire and simple switch and whatnot. It's either on or off, but it's pretty functional at the moment. It goes faster than I expected it would. I'm hooking up a charging setup, and Phil, you kind of helped with the design of this.
Me?
You and I emailed back, or I believe it was you.
Yeah, I'll take credit for it.
And you kept telling me, it's like, no, that won't work. You will short everything out. And then I would try something else, and he said, no, that doesn't work. And you sent me these awesome diagrams, and it helped me figure out how to make it so I wouldn't blow stuff up.
Yay.
So I would at least the
blow stuff up if you want to.
What's that?
You should only blow stuff up if you want to.
Exactly.
All right, well, your scooter looks awesome. Stay safe, of course, wear a helmet, but all it needs is a sticker. So don't forget to email support Adafruit to get your show and tell sticker. You can put it on the bottom.
All right, sounds good.
All right, thanks, Dan.
All right, looks like we got
Great,
one more
thanks.
person that maybe we'll try to squeeze in. We'll see how it goes.
Okay.
They
Christoph, we don't see
They
you.
are blank. So I think we're going to call it because we have to set up for the next show.
Okay.
Now that we're using StreamYard, it takes a couple extra minutes. So that's our show and tell tonight.
right.
For everyone, thank
Thank
you.
you.
Thanks for making this the best 28 minutes of our week every single week. We're here next week, 7:30 p.m. Eastern Time. Don't forget. We do have the AdaBox unboxing, but we will be doing the show and tell anyways. And then a lot of stuff that you saw or had a couple previews of will also be on Ask an Engineer tonight.
True.
So hang out, hit
True
refresh, and we'll be back in just a few minutes.
All right, thanks, everybody.
Bye-bye.
See you next week.